Alright, let's take a look at rational exponents. Now, the definition of rational exponents is that if you have a particular base b raised to an exponent that happens to be a fraction, it can be written out as b underneath the radical sign. The q, the denominator of your fraction, becomes the index, and the p becomes the exponent. Now, it can be written with the p on the inside, like so, or it can be written as p on the outside, like you see down here. It absolutely does not matter. The big thing to remember to try to get this straight is that x to the 1/2 power is the square root of x, because your index is 2 and your power is 1. But that's normally what I write on the top of my paper to help remind me where all the numbers go. So the directions here say express the following in simplest radical form. So we're going to get rid of the exponents and we're going to write them as radicals. Each one of these, since they have a fraction exponent or rational exponent, is going to change to a radical. The denominator is going to become your index. Your base is going to be what goes under the radical, or your radicand. And the number in the numerator of your rational exponent is going to be your exponent. So the cube root of 8 to the first is just the cube root of 8, or 2. Same thing here. We're going to fill the 4 in. The denominator becomes the index. The numerator becomes the power. I tend to write the powers on the outside here because I normally try to evaluate the roots first, but it's up to you. I know the square root of 4 is 2, so this would leave me with 2 cubed, in other words, 8. For 64 to the 1/3, we're going to fill in the 64. This is going to be the cube root of 64 to the first. The cube root of 64, you can check it in your calculator, or you can tree it down, but the cube root of 64 is 4. And this last one, 81 to the 3/4. So we're going to fill in our 81. The denominator is going to be the index, and the numerator is going to be the power. So again, it's up to you. I'd like to do the 4th root first because I know the 4th root of 81 is 3. So this question is really just asking for 3 cubed, which is 27. Now keep in mind, you need to be able to put this 4th root into your graphing calculator, so make sure you do know how to do that. Let's take a look at a couple more examples. 49 to the -1/2. Everything you learned about negative exponents still holds true. So if this is a negative exponent, this 49 needs to go to the denominator of our fraction. We are still going to fill in the 49 as our radicand. The denominator of my exponent is going to be the index. The numerator is going to be the exponent. So I have 1 divided by the square root of 49 to the first. Well, the square root of 49 is 7. 7 to the first is just 7. Now, you do need these in fraction form. They cannot be in decimals. So remember, if you do not know how to write a decimal as a fraction, type it into your calculator and hit math, enter, to get that decimal to change to a fraction. So when you type in 1.5 into your calculator, you will get 3/2. So then we're again going to change this into the root. Denominator is your index, numerator is your exponent. So the square root of 9 is 3, 3 to the 3rd is 27. 1/8 to the -1/3. Again, deal with the negative first. So I would flip this fraction over and rewrite my exponent as a positive. Then I can change this to the cube root of 8 to the first, in other words, 2. Now, rational exponents can go the other way. If your directions say express using rational exponents, we're going to go from a radical to an exponent. So 5, the square root of 5. Again, I always write up here on the corner of my paper, x to the 1/2 is the square root of x. So I know I can take my radicand 5, and in this case, square root is just to the 1/2. That's all I'm asking you to do, is to take it from radical form to rational exponent form. Now, if you have multiple factors underneath your radicand, each one needs to have its own exponent. So right now, 7 is being raised to the first power with an index of 3. 7's fraction is going to be 1/3. X's fraction is a 2/3, since its original exponent was 2. Y is also going to be to the first, like the 7, so it's going to be 1/3. And it does not matter if, say, you can reduce these, like the cube root of 8 is 2, you can write that as 2, or since I'm just asking for rational exponents, you can write it as 1/3. What I want you to be aware of is this situation. If I ask for rational exponents, I do want them reduced. 6 divided by 3 would be 2, and that would be my answer for rational exponents. Now, there's a kind of weird question here. Try to express the cube root of 16 in 3 different ways. I want you to pause the video and see what you can come up with. Take a look what I came up with. I have 5 different ways here to express the same thing. That was just kind of an activity to get you to start to think about rational exponents and also bring us back to regular exponents. Next, we're going to look at expressing things in a single radical. If you notice here, we have r to the 1/2 times r to the 1/3. Now, if I were to write these as radicals, this would be the square root of r times the cube root of r. To multiply radicals, you need to have the same index. If you take a look above, where does the index occur in each of these fractions? In the denominator. In other words, we need common denominators for each of these fractions. The common denominator between 2 and 3 is 6, so we are going to write this first fraction as 3/6 and this second fraction as 2/6. Then it becomes easy to multiply. These are both 6th roots. The first one is r cubed. The second one is r squared. So this would become the 6th root of r to the 5th. You cannot reduce it from there, so it would say the 6th root of r to the 5th. Now, take a look up here. We have a 3, a 2, and a 6. So again, the smallest common denominator, the least common denominator, is going to be 6. So this would be 4 to the 2/6, a to the 3/6, and b is going to stay to the 5/6. We then can write this as one big 6th root, 4 squared, a to the 3rd, b to the 5th. Now we do want to make sure we cannot simplify anything here. I might write this as 16, but other than that, the 6th root cannot be reduced, and we are done. Sometimes there's kind of an interim step between getting from the fractions to the common denominators to the radical, and that would be true in this case. You would first need to write each of these using your rational exponent. So 6, the square root, would be 1/2 power. The 4 here would be to the 1/3 power. And again, the least common denominator here is 6. This would become 6 to the 3/6 and 4 to the 2/6. Underneath my 6th root, I would have 6 cubed times 4 squared. You can multiply that out, and the 6th root of 3,456. From there, you would want to reduce it if possible. Once you tree this all out, you will see you can pull a 2 out, and this would become the 6th root of 54. Now, for number 4, we already have a common denominator, so this would be the cube root of y squared times y to the 5th. When we multiply like bases, we're going to add exponents, so 5 plus 2 is 7. This again can be reduced. How many groups of 3 can you make with 7? You can make 2 groups to pull out with 1y remaining. And that's how you write rational exponents as a single radical. Now, don't forget you can do your regular laws of exponents using rational exponents. For example here, you can multiply like bases and add the exponents. 4/3 plus 2/3 would be 6/3. If we are dividing, remember you would take the bottom up and subtract it. 6/3 minus 1/3 would be 5/3, and that would be a simplified version of 1 like number 5. Now, you can go ahead and cross out these questions. You do not need to answer them.